Hi, welcome to part 2 of the reasons for the seasons. In this one we will actually talk about Earth's tilt and its relative position to the sun and how that plays a role in the seasons. So in the first part we talked a little bit about why it's cold at the poles and hot at the equator. It comes from the fact that the Earth is curved and the sun's radiation falls at an angle at the poles, whereas it doesn't at the equator. And that direct sunlight causes the equator to heat up a lot more quickly because the sunlight is more concentrated. There's more energy per unit area. Remember, it's the sun's light and the angle that warms the Earth, not Earth's distance from the sun. So let's talk a little bit more about the seasons and look back at the tilt. So here I have a globe and I have a yellow balloon, and the yellow balloon is going to represent our sun. It's just for position, completely not to scale whatsoever. And you'll notice that our globe here already has a tilt to it. So Earth's axis is tilted at a 23.5 degree angle. That's important because that determines that's what actually causes the seasons. If the Earth had no tilt, there would be no seasons. Now it's important to realize that Earth's tilt relative to the sun changes as the Earth goes around the sun. But the Earth doesn't wobble on its axis. It's not like the Earth's tilt goes back and forth like this. Okay, that's a really common misconception. What happens is that Earth's axis is always pointed at the North Star, Polaris. And as the Earth orbits the sun in a counterclockwise direction, the axis relative to the sun changes. So it's still pointed that way, but the sun is on the other side and the northern hemisphere is tilted towards the sun. So as it goes around, this would represent southern summer and northern winter, and 6 months later, as it orbits around the Earth, as it orbits around the sun, this represents northern summer and southern winter. So let's continue on with the diagrams and the notes that I've provided. So here we're just picking up where we left off in the notes. Up here we have the last diagram where we talked about a little man standing at different positions around the Earth and whether or not he would see the sun at the horizon or low in the sky or directly above his head. So now we're going to take a look at the diagram for the seasons. So here we can see a diagram where Earth has its tilt, 23.5 degrees. The sun's rays are still arriving parallel, and we can see that the sun's rays arrive most directly right here. It's still in the middle, but the middle isn't the equator anymore. The middle, because of the tilt, is 23.5 degrees. So 23.5 degrees south and 23.5 degrees north are the Tropic of Cancer in the north and the Tropic of Capricorn in the south. So here, the sun's rays are landing on the Tropic of Capricorn. Now, take a moment, look at this diagram, try to figure out, is this northern summer or northern winter? This is northern winter. And if it's northern winter, it is southern summer. So let's go ahead and make a diagram of the seasons. I'm just going to adjust the camera very quickly so you can see the whole diagram. This is extraordinarily important. I'm going to put a star on it because this will definitely and without a doubt be on the next exam and probably also on the final exam. So if I ask you to draw a diagram of the seasons showing the full Earth and Sun. This is the diagram that I want you to draw. So, here I'm going to start out with a classic picture of the sun. In science diagrams, even if it's kind of obvious, we want to label that. So I've labeled it sun. Now, the first one I'm going to draw is northern summer. This is the North Pole, and this is the South Pole. This is northern summer. Notice the axis is what marks the North Pole and the South Pole. The Earth actually spins on that axis, so it's spinning on a tilt. That's another very common misconception people have. So if you imagine the tilt like this, it's spinning around in this direction like that. Now over here, we'll draw the axis tilted in the same direction. Both of them are pointed towards Polaris, towards the North Pole, but in this case, because it's now on the other side of the sun, the axis is tilted away from the sun, and this is northern winter. Now, the southern portion of the Earth receives seasons in the opposite order of the northern seasons. So if this is northern summer, it is also southern winter. And this over here is southern winter. Now we're going to get into a concept that a lot of people have trouble with, and that's the idea of where is the sun in the sky where I'm standing. So we talked a little bit about latitude, and you might want to review those notes if you don't remember them very well. But remember, lines of latitude are the lines that are running from east to west that denote how far north or south you are. So on this first one, we're going to draw the axis totally upright. Now, remember, it's a relative position thing, and there's actually a time where relative to the sun, the axis is pointed directly upright. And that is when the Earth is on this side of the sun, basically in this diagram it would be behind the sun, or in front of the sun. That denotes fall and spring. We're going to draw imaginary lines of latitude, not terribly precise. Okay. And we'll say this right here is the line that is 44 degrees north. That's the line of latitude for Watertown. If I draw a little person here, I have to turn the globe. His feet, or her feet, doesn't matter, it could be his or her feet, are pointed down towards the center of the Earth, and the head is pointed upright. So, from this perspective, is the sun directly overhead at noon? Give you a moment to think about it. So no, the sun is not overhead at noon. In Watertown. It is overhead at noon right here at the equator, but it's not overhead at noon in Watertown. And that has to do with the curve of the Earth. Now, let's add tilt in here. I'm going to tilt this one this direction, and this one this direction. So, take a moment, determine which one is northern summer and which one's northern winter. This one on the left-hand side indicates northern winter, and this one over here on the right-hand side is northern summer. So the lines of latitude are at right angles to the axis, and we'll indicate this one as about 44 degrees north. And this one right here would be our equator. So now, if I put a little person standing here, feet facing down, because down is always the same, towards the center of the earth, head facing up, and I look, from this person's perspective, is the sun directly overhead? And the answer is no, it's not overhead. Over here, if I draw it for the equator, feet down, head up, is the sun directly overhead? And the answer in this case for the equator is no. The sun is not overhead. Not during winter anyways. Not during the winter solstice. And we'll get to the idea of solstices and equinoxes in just a moment. The only place it is directly overhead is right here, just south of the equator on the Tropic of Capricorn. There, the sun is directly overhead. Now let's try over here in northern summer. Okay, so let's take a look at a diagram that I drew earlier. So here we have northern summer, and we have the equator, and we have our 44-degree line. And if we look at the 44-degree line, which is where Watertown is, in the summer, the sun is not directly overhead here in Watertown. Here at the equator, once again, the sun is not directly overhead and is actually a little bit to the north. Whereas the perfect spot where the sun is directly overhead is the other tropic, which is the Tropic of Cancer, right here. So in Watertown, the sun is never going to be directly overhead. And that's what this diagram in your book is actually talking about. You might have seen this, and a lot of students get confused by this diagram. What is this diagram actually saying? What they're showing is that in the summer, the sun gets higher in the sky than it does sun is higher in the sky at noon. And in the winter, the sun is lower at noon. But in Watertown, the sun is never directly overhead. It's always a little bit to the south, which is one of the reasons why when you're planting, for example, fruits and vegetables, they sometimes say things like plant it on a south-facing slope, so it has that constant sun's exposure throughout the year. Now, what's a solstice and what's an equinox? The solstice is the longest day of the year, and the shortest day of the year in the northern and southern hemispheres. There are 2 of them every year, and the sun is directly over the Tropic of Cancer and the Tropic of Capricorn. actually, probably more accurately, over the Tropic of Cancer or the Tropic of Capricorn. So once a year the sun is directly overhead the Tropic of Cancer, and one time a year it's directly over the head at the Tropic of Capricorn. During the equinox, the day and night are each exactly 12 hours long, all over Earth. It happens 2 times a year, and the sun is directly overhead at the equator. So I hope that helped you understand the seasons. Let me know through private message or email if you'd like additional explanations. It's really important that you're able to recreate this diagram over here, and that you're able to interpret diagrams like this and understand important ideas such as the sun is never overhead in Watertown, but it can be overhead in places like the Tropic of Capricorn and the Tropic of Cancer. So, once again, if you need additional explanation, I'm always happy to do that. So, thanks for watching.